Welcome to repeated chain rule problems. So the idea here, sometimes we have sort of a series of function compositions. And so we need to sort of unpack those compositions in the derivative using the chain rule repeatedly. Again, sometimes a function is made of a series of compositions or multiple compositions. So when taking the derivative, we need to unpack the compositions by using the chain rule. Repeatedly. For example, let's go ahead and find the derivative of the function f of x equals sine squared of 2x cubed minus 4. So note when we have trig functions raised to a power, we write it in a slightly awkward format that makes function composition not so obvious. So let's just rewrite this. So the compositions are clearer. So we are really looking at f of x equals sine of 2x cubed minus 4, that entire thing squared. So we have our very outside function. Of something squared. And then in relation to that outside function, that inside will be u equals sine of 2x cubed minus 4. So we'll start with that. So if we want to take f prime of x, we are going to use the chain rule. And when using the chain rule, we therefore have f prime of x is equal to, we're going to first take the derivative with respect to u of the outside function, u squared. And then we'll multiply by the derivative of u with respect to x. So the derivative of u squared, we can use the power rule. That's just 2 times u. And then we multiply by the derivative of u with respect to x. Now we are going to plug back in u. So this is equal to 2 times the sine of 2x cubed minus 4 times the derivative of sine of 2x cubed minus 4. Now at this point, we have to take another derivative. And once again, we have a function composition. So here we have the outside function is sine of blah We can use u again or v if you want to use a different variable. This time around our inside, let's use v, is 2x cubed minus 4. So you've got sine of v, where v is 2x cubed minus 4. So we are going to once again use the chain rule. And we have f prime of x is equal to the first part, 2 sine of 2x cubed minus 4 stays put. Then we will do the derivative with respect to v of sine of v. And we will then multiply by the derivative of v with respect to x. So we have 2 sine of 2x cubed minus 4 times the derivative of sine v is cosine of v times the derivative of v with respect to x. I need to give myself a little more room to finish this problem. At this point, we can go ahead and plug back in our v. So v was 2x cubed minus 4. If we plug that in, we are looking at 2 times sine of 2x cubed minus 4 times cosine of 2x cubed minus 4 times the derivative with respect to x of 2x cubed minus 4. And if we go ahead and take that last derivative, we have 2 sine of 2x cubed minus 4 times cosine of 2x cubed minus 4 times the derivative of 2x cubed minus 4 power rule. We pull that 3 out front, that becomes 6. 2 times 3 is 6, and then x squared. And if we then just simplify this, this becomes 2 times 6 is 12, x squared, sine of 2x cubed minus 4, cosine of 2x cubed minus 4. So this is using the chain rule repeatedly. We could have done other techniques. We do have trig rules, sine squared of x. We could have rewritten if we so wished in an alternative format. But we do not have to. And this lets us go through just using the chain rule. All right, let's go ahead and do one more problem. So if we look at this next problem, we need to find the derivative of g of x equals the natural log of cosine of x plus 2, that entire thing cubed. So again, we have an outside function of something cubed. We'll go ahead and name that u, and our inside would be u is equal to the natural log of cosine of x plus 2. So we are going to go ahead and use the chain rule. If you wanted to use we could always take that shortcut of the generalized power rule. So again, we will have g prime of x is equal to, our outside was u cubed. So we are going to take the derivative with respect to u of u cubed and then multiply it by the derivative of u with respect to x. Using that power rule, that derivative of u cubed is 3u squared multiplied by the derivative of u with respect to x. At this point, we will go ahead and plug back in our u. So u is the natural log of cosine of x plus 2. So we have 3 times the natural log of cosine of x plus 2. That whole thing squared. And then we have times the derivative of the natural log of cosine of x plus 2. At this point, we need to take the derivative of the natural log of cosine of x plus 2. Again, we have a composition. We only know natural log of x. So from here, we are going to again have an outside and inside function. Our outside has the natural log. Let's go ahead and call the inside v this time around. The inside would be v is equal to cosine of x plus 2. So we have, if we use the chain rule again, g prime of x equals, we still have 3 times the natural log of cosine of x plus 2, that entire natural log squared. Then we should have the derivative with respect to v of natural log of v. And then we have times the derivative of v with respect to x. So this becomes 3 times the natural log of cosine of x plus 2, the entire natural log squared. The derivative of natural log of v is 1 over v. And then we multiply by the derivative of v with respect to x. Well, v was cosine of x plus 2, so we can go ahead and plug that back in. We have 3 times the natural log of cosine of x plus 2, the whole natural log squared, times 1 over cosine of x plus 2, times the derivative with respect to x of cosine of x plus 2. At this point, we just have one more derivative to take. We still have our 3 times the natural log of cosine of x plus 2, the whole thing squared. We still have our times 1 over cosine of x plus 2. And finally, the derivative of cosine of x plus 2. The derivative of cosine of x is negative sine of x, and the plus 2 would go to 0. So if we were to simplify this, rewrite it out, we essentially have 3 times the natural log of cosine of x plus 2, the whole natural log squared, times, I'm going to go ahead and put that negative way out front, so it becomes negative 3. And then we'll have a sine of x over cosine of x plus 2. So the repeated chain rule, the problems do get lengthy. I recommend very clearly writing out it may be useful even to put the things you still have to derive in a different color, right? So if we wanted to say just highlight the things at this point, we still need to take a derivative. At this point, we still need to take a derivative. Right, we're back to x's, but still need the derivative. It may be useful just to have that to remind yourself, we're not done yet. We still have to do this part. All right. But that is repeatedly using the chain rule.